We're looking at question 7, and question 7 is about the area rule, assigned rule, etc. Right. So let's discuss that, and then I'm going to spend more time on the other topics as well. Right. In the diagram, what we have here is that the angle P itself is 67 degrees. The PQ is 3 centimeters, and we have that PR is 9,2 centimeters. Determine the length of QR. We just need the length of QR there, right? So we have this, and at grade 11, it's very important that you understand this. Because it is part of what you need to do this term, at the beginning of this term at least, and then the probability will then be done. So this is 3 centimeters, this is 9,2 centimeters, this is 67 degrees. And therefore, you need the length of QR, which means at this point, you can find the length of QR. Right, so what is the length of this QR? Right, so there are a couple of ways to find the length of QR, for example, and therefore, the easiest way to find the length of QR is to use the cosine rule, which means you can realize opposite angle Q is small q, opposite R is small r, opposite P is small p, which means we can be able to get the QR squared. So QR squared is the same as what? Right, so QR squared is the same as Q squared plus R squared minus 2 QR cosine P, because QR is opposite the angle P. Right, in which case, some students can prefer to use the sides and say small p squared is equal to, for instance, Q squared plus R squared minus 2 QR cosine angle P. Okay, right, what is this? Which means PQ, what is Q? Is 9,2. What is R? Is 3 squared minus 2. Q is 9,2. And then R is 3 cosine 67 degrees. Right, so which means P is, now you can get P squared. What is P squared here? Right, so P squared at this point is exactly what? Right, so P squared is exactly what you need to get. So it becomes, therefore you can take the square root on the left, then you can take the square root on the right. So which means it is 9,2, which is square, plus 3 squared minus 2, 9,2, 3 cosine 67 degrees. And therefore, we can get P if you find the square root, both left and right, because we want to remove the square. And therefore, the square root of the right-hand side, if you find the square root of everything, the 9,2 squared plus the 3 squared and everything, what is the answer? So use a calculator to do this, and the calculator will tell you that exactly this P is approximately 8,49 centimeters. Okay, that's the answer. So it's 8,49 centimeters, and that's the answer. So we have found this one, which is 8,49 centimeters, and that's the answer. We're done. Right, so we used this rule, which we call the cosine rule. Okay, I'm just recapping on that because it's very important. So this lesson is being recorded. Please enable to see my screen. Is that correct? Right, if you're able to see my screen. Okay, thank you. Because last time the screen was not visible to you, and I didn't know it because, see, sometimes I can't see what you are able to see, you know? So, right, so it's very important that you're able to see the screen for the recording, because it records what you can see, not what I can see. Okay, right, in the diagram below, what you have is the following, for example. Right, what you have is the following here. You have that the angle DCB, right? So there is D, the C, and this B, and this angle is alpha. AC is H. AC is H. So here is A, and this is H. ACB is theta. ACB is theta. Determine the size of ACD in terms of theta and alpha. Determine the size of ACD in terms of theta and alpha. Right, so let's do that one. You need to determine A, C, D in terms of theta and alpha. Need to determine A, C, D in terms of theta and alpha. Okay, which is this one? So this one is pretty straightforward, and you need to learn that. How do you do this question? So at this point, it is clear that angle ACD is equal to theta minus alpha. So it is theta minus alpha, because theta is everything. So you take the whole angle minus this little bit is going to give you this one. Right. So that's just angle subtraction, or actually angle addition. Right. It's the addition of two angles. Because there are a couple of ways to do this. Another way to do this, another student can say, at this point, you can say, for example, you can say angle alpha in the diagram. Look at the diagram very carefully. Angle alpha, or we can start by saying angle theta. You can start by saying angle theta. Right, you can start by saying angle theta. Just 1 second, 1 second, 1 second. I just got my screen messed up because of somebody just decided to send a communication. Just got my screen messed up because somebody decided to send a communication. So I will just sort that out. Let's see now what I can do here. Just 1 sec. 1 sec. Need to remove this. The guy has presented the challenge. Just 1 second. Right, so just 1 sec. I need to restore my screen. Need to restore my screen. Don't know why somebody just decided to chat. Let me get to this split screen. Okay, right back. And therefore, we have 7.2.1. And therefore, in 7.2.1, we have that. I was saying basically, at this point, what you need, for instance, is to say, somebody can say the angle theta. So this is an alternative. Or the angle theta is alpha plus ACD. Okay, you can say the angle theta is actually alpha plus ACD. So if you have ACD, you take ACD, you add, you get the whole angle, and the whole angle is theta. So in which case, therefore, you can just do an angle addition. So ACD equals angle theta minus alpha. Okay, so you can do that kind of angle addition. Now, the next question is 7.2.2. You need to prove that you have that angle AD is exactly that one there. Right. We continue. Right, so we have 7.2.2. You have AD. Right, so you have AD, now you have this one is A and this is D. Right, so you have AD, you need to prove that AD is this one, right? So to prove that AD is this one, you can realize that. So you'd have, for instance, this, that, and you extend like this. And then you have this one is A and this one is D. Right, so this one is theta minus alpha. So that this is A, D, and this is H. And therefore, okay, so what do we do now? So you have these. So at this point, then you need to get your AD, and this is your A, and this is your D. This angle ACD, this is C, is ACD. This angle here is what we are talking about, ACD. So what is this? Well, we're able to see, therefore, that at this point, what is ACD by using any of the rules that we know. Right, so we can use the rules that we know and be able to get this one right. So you have that angle D1, just note that, angle D1. So angle D1 is this one here. It's equal to this plus this. So angle D1 is 90 degrees plus this angle is alpha. So angle D1 is 90 degrees plus alpha. So which means that you have the sine of 90 degrees plus alpha. So the angle D1 is 90 degrees plus alpha. 90 degrees plus alpha. So the sine of 90 degrees plus alpha over h okay, which is equal to the sine of 90 degrees plus alpha. The sine of 90 degrees plus alpha over h is equal to the same as the sine of, okay, let's look at this one, the sine of theta minus alpha. Okay, we are looking at the triangle on the right of the page. So you have the sine of 90 degrees plus alpha over h is equal to the sine of theta minus alpha over AD. So cosine alpha. Which is exactly the sine of AD. So what is AD? So AD now can be obtained out of this. So AD is exactly H. So you can cross multiply out of this. Okay, let's just cross multiply to practice together. Cross multiplication. So if you cross multiply like this is AD cosine alpha is equal to H, the sine of theta minus alpha. And therefore, you're able to get AD if you divide by cosine alpha, which means AD is the same as H, the sine of theta minus alpha, divided by cosine alpha. 7.2.3, so this becomes the answer. Determine the length of AD. Right, so this is recorded, so don't worry about copying the things here. Determine the length of AD if H is 17 units and theta is that and theta and alpha is that. All right, so what is this and how do we determine therefore the length of AD? Right, if you have been given H, so H is given, theta is given, alpha is given, so you can use just exactly the previous answer. So we're able to see that AD is H, the sine of theta minus alpha. What is H? 17. theta, 58 degrees. Alpha is 23 degrees. Alpha is what? 23 degrees. Okay, we use this calculator, rather this formula to get the result. And if you do this, you're able to get 10,59 units. Okay, so that would be, all right, 10,59 units, so in other words, AD is approximately that. Okay, so it is 7.2.3. All right, so calculate the area of a triangle ADC. So the area of triangle ADC, what is the area of this triangle here? Okay, right, so we can find the area. So look at this now. Triangle ADC, need to find the area. So you're gonna have this. You're gonna have this. You're gonna have this. You're gonna have this. Okay, so you're gonna have this. You're gonna have D. 1 ACD H. This is angle D1. So if this is the case, you can remove this. Right, if this is the case, what do you achieve now? We want to find the area of triangle ADC. So the area of triangle ADC is half. Look at the lengths that you have. What lengths do you have of the sides? We already have AD, which is 10,59, and you already have H, which is 17 units. So we look too good, right? So which means we can use that. You can say the area is half AD because we already know the length of AD. And then now we also say it is half AC because you already know AC, times the sine of the angle included by the two sides mentioned, and the angle included is the angle A by the two sides. And therefore, the area of triangle ADC is half. What is AD now? 10,59. What is AC? It is 17. The sine of 32 degrees. So which means the area of triangle ADC, which is 47,70 units squared. So that is exactly the answer. So ADC is actually 47,70 units squared. That is the area. Or square units. So we can also say in 7.2.4, the answer we can say it's approximately 47,70 square units of area. Now there's something else. Question 8, we are doing another section, and this section is on mensuration. Okay, so we're looking at question 8. Now, if you look at 8.1, the diagram below shows a cone with a perpendicular height h and a radius r centimeters and a slant height of 13. Here's the slant height. Right, the volume of cone is 1/3 pi r squared h. The total surface area of the cone is pi r squared pi rs. Show that the volume of the cone is given by this. So we just need to find the volume of the cone. How do you find the volume of the cone? Right, so to find the volume of the cone, first things first, we need to find the, so you need to look at the cone. Here is the cone. Here is the cone. And then now this is that, and this is that. And then now, so you have this. So this is 13. So what is this now? Now we can use Pythagoras theorem because now you have this. So Pythagoras theorem will tell us that this is a right angle triangle. So if this is a right angle triangle, the red one, you'll tell us that 13 squared is actually h squared plus r squared. That is Pythagoras theorem. Okay, so if this is the case, we get 169, which equals h squared plus r squared. So we want to get the r squared, which means r squared is the same as 169 minus h squared. So what is the volume? Okay, so we continue with this. So the volume is the same as what? Is the same as 1/3 the area times the height, the base area times the height. Okay, the base area times the height. So okay, so you continue. So the base area times the height, that is the volume of anything, is the base area times the height. Okay, so you have this. Okay, so you have the base area, which is the volume of this is the base area times the height. So you have this. What is the base area? Well, the base area is a circle, so you have this. So as a consequence, we good. So the base area is a circle, so you have pi r squared and then times the height, so which means this. So what is that? So it's 1/3 pi, and then the r is the same as 169 minus h squared. Right? Because we got r to be 169 minus h squared times the height h. And therefore, we're able to multiply everything here. And if you multiply everything, it is actually 169 pi minus the pi h squared. So it will be pi h cubed. Pi h cubed. Over 3. And this is it. The third proof that the volume is 169 pi h minus pi h squared over 3. So that's what we got exactly. Now we move to the next question. The next question is part B of the question. And part B of the question is, if h is 12, determine the total surface area of the cone. Right, so we're going to determine the total surface area of the cone there. All right, so let's just do that one. Right, so we're going to look at 8.2. Right, so in 8.2, you have that h is 12 centimeters. Determine total surface area of the cone. So which means that at this point, we remember that r squared is equal to what? R squared is 169 minus h squared. So okay, let me see. All right, so you think this Zoom went out? All right. That's fine. It must be recording. It must be recording because I didn't lose you completely. I didn't. Okay. Yeah. You can see my screen now, right? Welcome, welcome. So this is 169 minus h squared. Are you here now? So r squared? Yes. Okay, thank you. I'm so sorry. Yeah, always notify me with WhatsApp if you are lost. Okay, I'm expecting the recording not to be disrupted. I'm going to send you the video to the lesson today. So this is 12 squared, which means it is the square root of 169 minus 144. Okay, the electricity will go very soon. And this one is the square root of 25, and it is 5 units. So which means h is actually 5. So, okay, always notify me if Zoom goes out because it happens sometimes. It's network issues, so sometimes those issues just beyond our control, which is related to the network, because you didn't know why it just can just disconnect. So you have the total surface area. What is the total surface area of a cone? Total surface area of a cone is pi r squared plus pi r times the slant height. So that is the total surface area of a cone, pi r squared plus pi rs. So it's pi into 5 squared plus pi into 5 times 13. So you add everything here, which is 90 pi. So which means it is exactly 282.74 square centimeters. So which means that the total surface area of the cone is 282.74 square centimeters. Right, so we've done a couple of questions now. We've done question 8 of this paper. We've done question 7, the sine and cosine rule. Right, so because the electricity is about to go in the next 2 minutes, I think that we're going to take a break now. And we're going to return again because it's going to be back at our time at 2, right?
Yes.
Yeah, so is this going to be back at 2? I'm going to send the recording before 2, obviously. What time do you suggest to meet? Can we have our lesson at 6?
What time? 6.
Yeah, how is 6?
Okay, it's fine.
Yeah, okay, we're going to have our lesson at 6. Okay, I'm going to do more things at 6. All right.
Okay.
Yeah, thanks, but I'm going to send you this video that we've done today, and I'm going to send you the material we just did. Okay, but yeah, the video can only be sent in about 30 minutes after the lesson. So yeah, but this one is okay because you're able to see my screen, so the video is going to be fine because it records what you can see. But thanks a lot, and we'll talk again at 6, but I'm going to send you this video in 30 minutes time. Okay.
Okay.
Okay, thanks, Dan, and goodbye.
Bye.
Goodbye.